Hi guys, today we will consider 3 examples. Let's begin. Suppose we're given the system of linear equations. Our task is to solve it. As we know, linear equation represents a line on a plane. So by solving the system of linear equations, we mean finding the intersection point of 2 lines. So let's find this point. First we need to transform our equations into slope-intercept form. The first equation gives us the following: y equals 2/3 times x minus 1/3. The second equation gives us y equals 0.5 minus 2x. So here's our system now. Let's have a look at the slopes of the lines represented by these equations. The slope of the first line, k1, equals 2/3. The second line has a slope k2, which is equal to -2. So the slopes are different, therefore these lines are not parallel. And they have a unique intersection point. Now to find this point, we need to equate y's. We have 2/3 x minus 1/3 equals 0.5 minus 2x. Now we multiply the equation by 3. So we get 2x minus 1 equals 1.5 minus 6x. From here we get 8x equals 2.5, whence x equals 25/80. So here's the x coordinate of the intersection point. To find the y coordinate of this point, we need to insert x into one of the equations. Let's, for example, insert it into the second equation. We get y equals 0.5 minus 2 times 25/80. Here we reduce the fractions to a common denominator. The first fraction gives us 40/80, and here we get -50/80. So y equals -10/80 or -1/8. So we found the intersection point. Let's write it over here. This point is 25/80, comma -1/8. Now let's graph these lines. We need to have 2 points for each line to graph it. For the first line, let's pick x equals 0, then y equals -1/3, and for x equals 1, y equals 1/3. Let's graph these points. The first point is over here. The second is over here. So here's our first line. For the second line, let's also pick x equals 0, then y equals 0.5. And for x equals 1, y equals -1.5. So these points are over here. The first one is up here, and the second one is here. So it's line 2. And here's our intersection point, 25/80, comma -1/8. Now let's proceed. In the second example, we are also given 2 equations. The task is the same, to find the intersection point. Our equations are already in the slope-intercept form. So let's consider the slopes of the lines represented by these equations. The slope of the first line, k1, equals 1. So is the slope of the second line, k2. This means that the lines represented by these equations are either parallel or they coincide. Now let's have a look at the b parameter, which is the intersection point with y-axis. So b1 equals -4. This means that the line represented by the first equation intersects y-axis at the point 0, -4. b2 equals 12. So the intersection point with y-axis is 0, 12 for that line. As we can see, b1 is not equal to b2. Therefore, the lines represented by these equations are parallel. On the graph, it looks like this. We have two parallel lines. One intersects y-axis at -4, so it looks like this. And the second intersects it at 12. So these are the lines. Now our last example. We're also given two linear equations and we need to find the intersection point. The first equation is already in the slope-intercept form. Now let's transform the second equation. First we multiply it by 2. We get y minus 3x equals 4. This gives us y equals 3x plus 4. As we can see, we have two same equations. This means that these lines will coincide. So on the graph, we will have just one line. Summing up, there are three possible cases for two lines. The lines can be parallel. In this case, there is no intersection point and such a system will have no solution. Lines can coincide. In this case, we have just one line and there is infinite number of solutions for such a system. And the third case is when we have two different, not parallel lines. In this case, we have a unique intersection point and unique solution for such a system of linear equations. Thanks for watching us.